Okay, you ready to get your percentage on?
Of course.
All right. So percent yield and percent error, guys. We got all these percentage signs at the bottom. This is what we're going to talk about, and it actually ties into the mass-to-mass video that we looked at a little bit earlier. So let's get right to it. First thing I'm going to do is I'm going to show you an equation, and I'm going to point out a couple of key terms that we need to know. So the equation for percent yield is actual yield divided by theoretical yield, and I'll just shorten that word here, theoretical yield, times 100 to make it into a percent.
Okay.
So we know theoretical yield from the mass-to-mass video. What's theoretical yield?
So that's how much you should get. So how many grams you should get in your reaction if everything goes perfectly.
Right, so if I start with certain grams of one reactant, in theory, I should get a certain number of grams of my product. But we all know that nothing ever goes perfectly as planned, so that's why we have the actual yield. It's what you actually get when you carry the experiment out, not just in your head. Okay, so the other thing here is percent error. That is how much of a mistake you made. That is calculated by doing 100% minus your percent yield. It's basically everything that adds back up to 100%. So let's look at a real-world example here. Let's say you have a 10-question quiz, which you guys are very familiar with. And Ms. Angarasa, in theory, how many should you get correct?
Well, 10.
You should get 10 correct
Especially
every
on
time.
a chemistry quiz.
Absolutely. Now, let's say you actually get 7 correct.
That's not
Ew.
good.
Let's do this percent yield. So you actually get 7 correct. In theory, you should have gotten 10 times 100. What is your percent yield on that quiz?
70.
Yuck, 70.
And you're stuck with it.
You're stuck with that 70. Okay, so make sure we do better. Now, what about percent error? Can you do it just in your head looking at this?
So the difference between 100 and 70 should be 30.
Okay, so 100% minus your percent yield equals 30%. So here's your percent yield. Here is your percent error. And conveniently, they add up to 100%. Real world example, done. Chemistry example, let's do it.
Okay.
So let's say, well, I mean, this is actually a true story. I woke up one morning and I was like, man, I could really go for some fresh water. So I knew that if I combined hydrogen gas and oxygen gas, I could get my own water. And it just so happened that I had 10 grams of hydrogen gas just laying around. And I knew from doing my mass-to-mass conversion that I should make approximately 89.4 grams of high-quality H2O. All right, so I did my experiment. I didn't get 89.4 grams. All right, my actual yield in my experiment, because I didn't observe proper lab guidelines and everything, was 87.7.
Well, that's pretty close.
Yeah, but it's not really what I wanted. I wanted 89.4. But let's see what my percent yield was.
Okay.
So percent yield is going to be my actual yield, which was 87.7, divided by, what was my theoretical?
89.4.
I should have gotten 89.4. Multiply that by 100, and I end up getting 98.1% yield. Not bad.
Nope.
Not bad by college standards even, too. So what is my percent error, though? Well, this is pretty easy. All I got to do is 100%
minus 98.1.
minus 98.1%, which was my percent yield, and my percent error was 1.9%. Guys, if you're thinking, wow, this is super easy, that's it, you're right. It's pretty easy. It's just a couple of easy division problems and subtraction. All right, so
I got my message this time.
She's got her inspirational message.
Okay, if you are unwilling to learn, no one can help you. If you are willing to learn, no one can stop you. So keep on learning. See you next time.